All right, guys. So let's do 8.2. So 8.1 there. How are you guys doing on that one? Seemed okay. You guys seem to be doing all right there. If you haven't sent your homework to me though, can you guys make sure that you send that to me just by email? Like take a picture of the homework questions and then send that. Okay, perfect. So what 8.1 was, right? This was 8.1, right? This part of your notes there. So this should look a little bit familiar. So now what we're doing is this one. So this is 8.2. This is going to be our 8.2 stuff. So that's where we're going today. So it's a good reference, like I said, to kind of look back at this, to kind of remind you about, how things work here. So scroll down, go through some of the 8.1 stuff. All right, 8.2. Okay, so a few new terms here. So a line segment that joins 2 points in a circle is a chord. So we're going to be using that word a lot, a chord. So what a chord is would be something like this. Can you see down here? So you've got one side is attached to one side of the circle, and it's attached to the other side of the circle over here, and there's a line that connects them. So that would be called a chord. Technically, this would also be a chord, like the diameter of the circle from one edge to the other, right? But it could also be a chord if I have one from, like, let's say here to here, right? Oh, that was weird. Not that weird line that just showed up there, but this one, that would also be a chord, right? So anywhere on that circle, those are all examples of a chord. Okay. Next one, perpendicular bisector. Did we do this one in the last lesson? You guys heard that word before, right? I think so, yeah. The perpendicular bisector, it sounds super confusing. But the perpendicular bisector would be, actually, no, I don't think we did, sorry. If you took a line right from the center of the circle and we have some chord, right? Some chord from like here to here, some line from there to there. The perpendicular bisector is going to be the line that cuts this thing right in half, right? Do you see how like half of this green line is over here and half of it's over there? That's because we bisected it. That's what it means when you say like you bisect a line. Bisect means to like cut it in two. The word bi means two, right? Bisect. So we've cut that line right in two right there. So that's the bisect part of it. Does anybody have an idea of why we say it's a perpendicular bisector? Do you guys remember what the word perpendicular means? You can take your mic off, or you can type it. Or not, I'll tell you. Okay, so it's perpendicular because perpendicular means this, right? So like two lines that are 90 degrees with each other means they're perpendicular. So remember, parallel means that they never touch. Perpendicular means that they're straight up and down. So it's perpendicular and it bisects. So hence perpendicular bisector, right? And it's going to make an angle of 90 degrees there. So we can use that. We can do things knowing that. So here, 3 properties. These are going to be properties that we're going to use to do some math. So property number 1 is that the perpendicular bisector divides the chord into 2 equal parts. So what I just said there, right? So this is cutting this chord into, one part over here and another part over there, right? 2 different parts. Okay. It says the perpendicular bisector to a chord passes through the center of the circle. So it just means that it starts there, right? And it goes there. So it starts in the center of the circle and comes down to the chord. And then property number 3, the perpendicular bisector forms a 90-degree angle. So it's perpendicular, right? That's what we just talked about. So there's that. So now we can do some questions now. So let's do this question to see if we can figure this out. So this question says point O is the center of the circle. It says determine the value of B, and it says which circle properties did you use? All right, so we are looking for this length, right, from there to there. All right, so how are we going to do this? So what do we know? We know that it's 18 from here to here, right? From there to there. Well, can we do anything with that? What if we said, okay, well, I'm seeing a right angle triangle going on here, and we like right angle triangles, right? We were using a bunch of those last time. So it says this side's 90 degrees, but I know that that means the other side would also be 90 degrees. So I know that. It's telling me that one side of my triangle, right? That side of my triangle is 5. So I know that side. It would sure be nice if I could figure out what this length from here to here was, right? That side of my right angle triangle. Because according to the new properties that we just learned, are you guys okay with saying if I figure out that red length there, that would be the same thing as B, right? Because it cuts it in 2. So we're gonna have, so if I just find this length, I should be good to go because that length would be the same as that. All right, so let's see if we can find this red length right there. So the way we can do that, we know this side is 5. Anybody know what this length would be? Can you guys tell me in the chat, or just take your mic off and tell me what would that length be from
9.
Yeah, great, 9, right? That really is the radius of our circle, right? The diameter was 18. Half of that would be 9. So I know that the hypotenuse of that triangle is 9. Some of you guys might be getting ahead of me here. You might even know where I'm going with this. So if I'm looking for this side right here, right? I can call that whatever I like. Let's make it, well, let's make it like actually using the terminology that you would. You'd say the length of this line was the length PS. So what I'm going to say is that PS squared is equal to 9 squared minus 5 squared. Are you guys good with what I just did there? How about you, Pedro? I'm just kidding, Grace, because he looks like he's behind you there.
Yeah, it's my virtual screen.
Yeah. So what I just did there, guys, was this. PS squared is equal to 9 squared minus 5 squared. That might look confusing, but that's just this, right? You've seen this where it was B squared is equal to C squared minus A squared, right? If this was B and this was C and this was A, right? This is just Pythagorean theorem, right? I didn't do anything magical there. This is just Pythagorean theorem. And I just put in, instead of a B, I called it PS because that's what the length of this side was. It was the length PS. Okay? So just Pythagorean theorem is all I did there. So let's actually do that. So we've got, you've got PS squared, the length PS, is equal to 81 minus 25. So let's do it all. We'll go square root. Here, actually, I'll do the middle step there. So we've got PS squared is equal to 56. And then, so does that make sense? Is this 56? No, very last thing, right? We got square root both sides. So square root. So we'd say PS is equal to, so square root of that is 7.5. 7.5. So PS is equal to 7.5. So that is 7.5. And then we've really done it. So if PS is 7.5, I'll show you guys a new symbol. I think we've done it a little bit. I think Hazlitt does it sometimes. So PS is 7.5. You guys know what this symbol means? It's like a triangle with 3 dots. Means therefore. So it says therefore B is equal to 7.5. Right? So if it says if PS is 7.5, B is also 7.5, just because this length is the same as that length, because it cuts it in 2. How you guys doing? Can you give me a thumbs up with a new, either in person or with your online one? Yeah, cool. All right, let's move on to the next one. Okay, so this one says, oh, I didn't actually say which properties we used, but you know what? You guys will be fine. I think I'll move on there. So point O is the center of each circle. So determine each value of R. Oh, I just took a snippet, so there's only one circle. It shouldn't say each. Determine each value of R. Which extra line segments do you need to draw first? Justify your solution. So we're looking for length R. So here's our center. They've given us some stuff, and they're saying, what's this length right there?
Hey, Mr. Brown.
Yep.
Could we still do Pythagorean theorem on that?
You can.
Technically a triangle.
Yeah, it's not technically a triangle, but you got the right idea. Like you're probably seeing what's going on here is that we really use Pythagorean theorem for almost all of these questions, especially for these first two topics. We use Pythagorean theorem for almost all of them.
Oh, okay.
Key here, though, is that we are going to have to figure out how to make it into a right angle triangle, right? There's no right angle triangle there yet, but we can make one. We're going to have to draw one line on this before we get going. And where I'm going to draw that line is going to be right here. So I'm going to start at the center, and I'm going to draw it down to the edge of that guy. Do you see how I've just made a right angle triangle? But now, that's not quite good enough, though, is it? Because I want to find the red side there, right, R. But I only know that that side's 2. I need 2 sides of the triangle if I'm going to figure out what R is. Any ideas there? Does anyone know what that green length is that I drew?
3.
It's 3. Good. Yeah, it's 3. How'd you know that?
Because it's just the radius of it.
Right. That is just the radius, right? So that's the key there to seeing this. So if you guys haven't noticed that, right? What he was saying is that, oh, that was weird. That wasn't supposed to happen. It's like shooting off. So if I start at the center and go this way, right? That's the radius of my circle. That's the same length as this one. I grabbed a weird pen. That's the same length as that one, right? The radius is still 3. So I can say that's 3. And now I'm good to go, right? Now I've just got the same thing. We've got Pythagorean theorem. So I'll just say R squared is equal to, and then just make sure you do this one right, because it does that. The order matters, right? It's going to be the hypotenuse first. So it'll be 3 squared minus 2 squared. So R squared is equal to 9 minus 4. So R squared is equal to 5. And then very last step, square root. So R is equal to the square root of 5. So I can say the square root of 5. So 2.2. That's it. Those ones aren't too bad at all, other than you just need to remember to draw that line in. The hardest part the kids have there is figuring out where to draw the line. So maybe I'll show you where people make mistakes on this. I see a lot of this, where people would like start from here and make a line up to there. That didn't do anything for me, right? That don't go that way. Yeah, that's usually what happens if people go the wrong way with that one. So, all right, let's do one more, maybe 2 if we have time here. So it says a diagram of a swimming pool is shown below. The dotted circle represents floating buoys or buoys. The pool has a diameter of 10 meters. Okay, so they've said the diameter is 10 meters. And it says the shortest distance from the buoys to the edge of the pool is. All right, so first off, what are we looking for? We're looking for this, right? The distance from there to there. That's what they're after. So the edge of the pool to where the buoys are. So now we do know some things, though. We know that that whole thing is 6. And we also know it says that the diameter of the pool is 10 meters. So we know the length from there to there. It was really straight, wasn't it? From there to there is 8 meters. And that's pretty much it. So anybody have any ideas yet? This is going to be another one of those ones where we're going to have to draw a line in.
Mr. Brown,
Yep.
am I missing something, or is the diameter 8 meters or 10?
Oh, sorry. Yeah.
Oh, okay. I thought I was missing something here.
Where did I come up with 8 from? 10
I
meters.
thought you did like some math that I missed.
No, just wrong. Yeah, so 10 meters, right? So, yeah. The way I would handle this one, guys, is you can see, right, that, well, very first thing that we're going to want to do here is make a new line, like I said. So the line that I'm going to make is going to be from the center out to the edge of one of the chords. So it can be from there to there. It also could have been from here to here. It actually wouldn't have mattered. I'll just erase one just so we have less lines on the page. And now that I've drawn that line, can anybody see from looking at that what the length of that blue line would be? Oh, I saw some lips move, but mics are still. Oh, I see people in the chat. I guess I got to open the chat. 5, yeah, good. Yeah, good. Okay, so you guys can see that that's 5. That's 5 because remember the red line there was the diameter. That was 10 meters, right? So the blue line is half of that. That's the radius. So that's 5 meters. Okay, so we're doing well here. I've made a right angle triangle here, right? That's a right angle. Anybody know what the length of, let's say, need more colors here. The length of that side is the yellow side. Anyone tell me in the chat there too? What would that length be?
3.
Nice. It'd be 3, right? Because it's always half, right? That cut this perpendicular bisector, cut that chord in half. So that's going to be a length of 3. So that's going to be 3. So now if I look at this triangle, I've got this side is 3. The hypotenuse is 5, right? You can see. And I just don't know what that length is. But anybody know why I'm even looking for that length? Can you guys kind of look ahead a little bit? Like why am I looking for that side of that triangle? Because this is going to help me find this length, right, from there to there. But what I'm really after is this length from there to there. So think about it. Try to see if you can figure out why I'm doing this. But I'll show you where we're going. Like in the end, maybe it'll make a bit more sense. So just for now, let's find that green length there. Just using Pythagorean theorem, like we've been doing. So I'll call that length just for a second to give it a name. Let's call it A. Okay, so let's call that length A. So that we'll say A squared is equal to 5 squared minus 3 squared. So that's going to be A squared is equal to 25 minus 9. So A squared is equal to 14. And then square root. So the square root of 14. You get A is equal to 3.7. Oh, shoot. That was stupid. Sorry, guys. 25 minus 9 isn't 14. 16. Thanks, guys. Tell me when I do things wrong, please. All right, so 16. So that's a lot better. So we're going to say square root of those. So square root of 16 is 4. Okay, so that's helpful. So now I know that this is 4. Right, so that length's 4. Now, how does that help us? Can anybody figure out? Take a second. Maybe you guys might be able to do this. You might be able to do it in your head. Knowing that that's 4, can anybody figure out what that length would be right there?
1.
Thinking 1? How'd you know 1?
Because the radius is 5.
Nice.
And then if you know that is 4, then you subtract 4 from 5.
Perfect, right? So what he was saying is that, okay, so if I know that this radius, right, from there to there, that's 5, right? Well, that means that this length from there to there, the whole thing, right? That's also 5, right? That's the radius, that's 5. So that 5 minus that 4, you'd be left with 1. So that must be 1 meter. So then we just have 5 minus 4 is equal to 1 meter. So answer would be A there. How you guys doing? Give me a thumbs up if that all made sense. Cool. All right, last one. You know what I'm gonna do, guys? I'm gonna pause this recording for a second. I'm gonna let you guys try this one. So here, I'll read it out. So it says, the arc in the diagram below forms a complete half circle. The block support beam in the diagram is 3.6 meters in length and is 3 meters above the surface of the water. It says, note, this diagram has not been drawn to scale. To the nearest tenth of a meter, the diameter of the arch is. So this one is looking for this to this, right? Or the whole thing. So the diameter of that arc. So what I'm going to do, I'm not even going to go through this one, but I'm going to maybe help you guys. Can you guys right now? Oh, you know what? Sorry, you guys don't have this on your sheet, do you? Okay, let's actually just do this one together. I forgot that you didn't have this in your notes. Okay, so what we're going to do here. So we need to make another line because they've told us, well, what do we know? So the block support beam is 3.6 meters in length. So this is 3.6 meters and is 3 meters above the surface of the water. So we also know that the length from here to here is 3 meters. And I'm looking for the diameter, but I'll give you a hint that I'm probably gonna, the way I'm gonna handle this is I think I'm gonna try to find one of these lengths, right? Like the radius. Oh, that was weird. Look at that. The smartboard's not being good. I'm gonna try to find the radius of this guy, and then once I know the radius, I'm just gonna multiply it by 2. Is gonna be the way we usually do this. So now I gotta make another line here to make a right angle triangle. It's kind of hard for you to explain where to put it, so I guess I'll just show you where I would put this line. Well, first off, I'll show you where the mistake would typically happen. A lot of times, a kid would draw from here to there to make their right angle triangle. Can you guys see that doesn't really do me any good? Because I don't know what the hypotenuse of that triangle is, right? That's not the radius of the circle. That's not really anything, right? So that didn't do me any good at all. So where I'm going to want to draw this line is actually going to be from the center of the circle up to that point. That's going to be more helpful because I actually know, well, actually, no, in this one I don't. Anyway, so let's do this. So we've got 3 meters up and down. Do we know what the length from here to here is? Remembering that this is a chord. Can anybody tell me in the chat what's the length? Yep, perfect. 1.8. 1.8. Oh, that's that color. That's going to be 1.8, right? That length on that chord, because that's half of 3.6, right? It's cutting it right in half. And I know that this is 3, so now I can just solve for my hypotenuse, right? I can solve for this guy. So let's call that length r, because it will end up being the radius. So I'm going to call that r squared is equal to, and then that's going to be 1.8 squared plus 3 squared. So r squared is equal to 1.8 squared plus 3 squared. So I get 12.24, and then very last thing, square root. So we get r is equal to the square root of that last number, 3.5. Okay, so 3.5, so great. And you'd be like, okay, perfect, because 3.5, and I did a bunch of good work, so the answer is A. But you would be wrong. The answer is not A. The answer is C. And the reason for that, right, is that what we just found here, right, this was 3.5, which is the radius, which means that this would also be 3.5, right? That's also 3.5. That's also the radius. But just be careful because the question was saying, what's the diameter? It was saying, what's the length from there to there, the whole thing? So 3.5 times 2, right? So that's going to be 3.5 times 2. So the answer here was 7.0 meters. Okay. So that's it, guys. You've got your formative questions to do.